Today our video is about cosmic radiations. Do you know what cosmic radiations are and how they form? Do you know about the effects of cosmic radiations on people in space? Do you know cosmic radiation can affect the electronic gadgets and electronic transmission? What is cosmic radiation? We are constantly exposed to low levels of radiation. One natural source of radiation is from space. This type of radiation is called cosmic radiation. Cosmic radiation consists of high-energy charged particles, X-rays and gamma rays produced in space. Charged particles react with the Earth's atmosphere to produce secondary radiation which reaches the Earth. Cosmic radiation is produced by the stars, including our own Sun. Another form of radiation that comes from our Sun is ultraviolet, UV, radiation. UV radiation is not considered cosmic radiation. Unlike cosmic radiation, UV radiation is lower in energy and is considered non-ionizing radiation. Radiation dose due to cosmic radiation will vary with altitude. Higher altitudes mean greater exposure to cosmic radiation. Cosmic radiation is more intense in the upper atmosphere and most intense in deep space. Scientists are trying to trace back cosmic ray origins by looking at what the cosmic rays are made of. Scientists can figure this out by looking at the spectroscopic signature each nucleus gives off in radiation, and also by weighing the different isotopes, types of elements that hit cosmic ray detectors. The result, NASA adds, shows very common elements in the universe. Roughly 90% of cosmic ray nuclei are hydrogen, protons, and 9% are helium. Hydrogen and helium are the most abundant elements in the universe and the origin point for stars, galaxies and other large structures. The remaining 1% are all elements, and it's from that 1% that scientists can best search for rare elements to make comparisons between different types of cosmic rays. The Pierre Auger Observatory collaboration found some variations in the arrival trajectories of cosmic rays in 2017, providing some hints about where the rays could have originated. Scientists can also date the cosmic rays by measuring the half-life of each nuclei gives an estimate of how long the cosmic ray has been out there in space. What effects does cosmic radiations cause to people in outer space? Earth's magnetic field and atmosphere shields the planet from 99.9% of the radiation from space. However, for people outside the protection of Earth's magnetic field, space radiation becomes a serious hazard. An instrument aboard the Curiosity Mars rover during its 253-day cruise to Mars revealed that on even the shortest Earth-Mars round trip would be about 0.66 sievert. This amount is like receiving a whole-body CT scan every 5 or 6 days. A dose of 1 sievert is associated with a 5.5% increase in the risk of fatal cancers. The normal daily radiation dose received by the average person living on Earth is 10 microsieverts, 0.00001 sievert. The Moon has no atmosphere and a very weak magnetic field. Astronauts living there would have to provide their own protection, for example by burying their habitat underground. Has no global magnetic field. Particles from the Sun have stripped away most of Mars' atmosphere, resulting in at the surface. The highest air pressure on Mars is equal to an altitude of 22 miles, 35 kilometers, above the Earth's surface. At low altitudes, Mars' atmosphere provides slightly better protection from space radiation. In 2017, NASA made some, located at the Brookhaven National Laboratory in New York, to do more studies into how cosmic rays may affect astronauts on long voyages, including to Mars. These upgrades allow researchers to alter types of ions, and the intensity of energy, more easily due to software control. Effects of cosmic radiation on electronic transmission? Energetic particles can ionize atoms and displace them within their crystalline lattice. For instance, solar panels on spacecraft that leave the Earth's atmosphere lose performance due to cumulative effects of displacement damages induced by energetic particles. A large solar energetic particle event can, within some days, cause the same degradation as an entire year of operation under the effect of only galactic cosmic rays. Ionization is often the dominant mechanism by which the performance of onboard electronics degrades. Mechanical and electrical insulating properties of Teflon can also be changed when the material is irradiated to high levels, as well as painting used for thermal regulation. All this decreases the lifetime of the equipment. Energetic electrons also create different types of damages when they penetrate into the spacecraft and deposit their energy in electric charge. At some point this may create a discharge that interferes with instruments and detectors, biases instrument readings, leads to the erosion of materials. The depth of penetration, and the region where the problems occur, depend on the particle energy. Aircraft operations on polar routes are also affected by energetic particles and the secondaries they create in the Earth's atmosphere, because these particles alter the state of the atmosphere, especially the polar atmosphere, which is less protected by the Earth's magnetic field. The numerous protons of relatively low energy that can penetrate down to heights of 50 to 70 kilometers above the ground ionize the polar ionosphere. Electronic devices at spacecraft altitudes have the least protection by the Earth's magnetic field and are vulnerable to the full impact of cosmic rays.